Hello, Maurits here, and welcome to this little video about random variables. So, what is a random variable? A random variable is the result of a random event, and we usually write random variables with capital letters compared to ordinary variables that are usually written with small letters. An example could be the variable x, i.e. the capital X here, is the result from throwing a die, so x could be any of the values 1, 2, 3, 4, 5, and 6. Or x could be the number of pets a randomly selected person has. So we ask a random person how many pets you have. Like me, I would say 1. So for my part, the result of this random variable would be 1. Z could be, for example, how tall a randomly selected person is in, for example, a class or something, or in a school. So if you make a sample and ask a bunch of people about how tall they are, then Z will be the value they give. Hopefully they give the correct value. A bit of revision here. A discrete variable can only have fixed values, like in x and y, right? X could only have particular values. Y also could have only particular values, whilst the continuous variable can have any value in an interval, like z. When you grow, you doesn't suddenly grow from 157 to 158 to 1 and so on. You have all the values in between also, even if we just write down the values to the say nearest centimeter. And if you see an expression like p and then bracket x equals x, that is a way to write what is the probability that a random variable x gets the value small x in an experiment. So for example, for die, if you can write probability that capital X equals to 6 is 1/6. The probability for capital X to be 2 is also 1/6. So in this case it will be 1/6 all over. So let's look at an example which is slightly more varying, so to speak. Say we have a random variable x that is the result after throwing a particular die. So say we have a die with one side has one eye, two of the sides has two eyes, and three of the sides have three eyes. And the random variable x is the result after throwing this particular die. So the probability that our result after throwing the die is 1 equals to 1 out of 6, right? The probability that our random variable happens to have the value 2 happens to be here in this case 2 out of 6, and the probability that our random variable x equals to 3 is, because of how we designed this die, 3 out of 6. So we can also write this as a table. So we have x and probability, that is small x, and the probability that our capital X equals to our small x. And our small x, maybe I should indicate that more clearly. I write that more clearly as a small x. So we could have for this die the results 1, 2, or 3, and the probability for 1 is 1 out of 6, probability for 2 is 2 out of 6, and probability for 3 is 3 out of 6. This here is called a distribution, or probability distribution. So basically the distribution is how the different probabilities are distributed along the possible results. In this case, we wrote down the distribution as a table, but we also, and that is not always the case, but we can also write in this case the distribution as a function, because it happened to be so. I designed this distribution such that it would be x divided by 6, right? Small x divided by 6, where 1 is less than or equal to x, which is less than or equal to 3, right? Or even better, x belongs to 1, 2, 3. And the possible outcomes of an experiment is called the sample space. So what kind of questions could you expect to get on this? You could, of course, be asked to find the average and so on, as we did in the last video, but we will look at that in the next video. So Another type of question is this, that you are given some kind of distribution, and this is very similar to exercises we also had done previously. Let's say x could be, say, 1, 2, 3, or 4, and the probability that capital X equals this x, the first x should be a small x, is say 0.1, in other words 10%, 0.2, 0.3, and some probability p. So suppose we should define this value p. And of course we know that the sum of probabilities should always be 1. So we know that 1 minus these, so 0.1 plus 0.2 plus 0.3 should be equals to x, right? Because we add up all the probabilities to be 1. So this will be 1 minus 0.6 equals to p equals to 0.4. So that is a quite straightforward example. But we could have a slightly more complicated example. So say we have x again. Could be, say, 1, 2, 3, or 4. And the probability that capital X equals to small x, so that the capital X has that particular value, is, say, 0.1 again, so 10% for 1, say 0.2, or 20% for 2, p for 3, and p squared for 4. And yet again we are asked to find the value of p. So what do we know here? We know that 0.1 plus 0.2 plus p square must be 1. The sum of these probabilities should be 1. So we can rearrange this to an ordinary quadratic. So p square plus p, and then we can see if we subtract 0.1 plus 0.2, subtract the 1, that would be minus 0.7 equals 0. And suppose we have access to calculator, so then we go into the calculator. We can go into the equation solver here, and we go to polynomial, degree 2, and the coefficient in front of p square is 1, in front of p is also 1, and then minus 0.7. Solve, and we get 2 solutions. So either p equals to, what was it now again, 0.475, or p equals to this value here, minus 1.47. But we can immediately see that 1 minus 1.47 doesn't work because the probability will be outside the range, and so that one we can remove. You could get 2 different solutions that actually both of them work, and then you would answer both solutions, right? But in this case, it's only one possible value for p, 0.475, or 47.5%. So that kind of exercises could happen quite often, but it should be quite familiar because you have done something similar in earlier chapters, right? So thank you. I hope this helps.